Station, this is Houston. Are you ready for the event?
We're ready for the event.
JSC PAO, this is Mission Control Houston. Please call station for a voice check.
Station, this is Chelsea Bayarte with JSC PAO. How do you hear me?
Hello, Chelsea. We've got you loud and clear.
Andreas, Jasmin, and Satoshi, it's so great to see you. Thank you for taking the time to talk to us this morning. I have some special guests here with me who are eager to ask you about your science that you've been conducting, and we'll also hear from some members of the media with their questions later on. So for media calling in on the phone, please press *1 to enter our question queue. And as our guests on the phone bridge are getting their questions ready, I'll hand it over to NASA Administrator Bill Nelson and Dr. Lisa Carnell, the Division Director of NASA's Biological and Physical Sciences Division. Administrator, please go ahead.
Hey guys, you're looking pretty good. Thank you for what you're doing. And what we want to do is bring to light more of what you, in fact, are accomplishing up there in the way of science research, medical research, and all kinds of research. And so there are a lot of things that, you know, are just now coming into their own. We've had the station up since 1998, when the first 2 modules were put together, and now we've got this huge structure in space that's 120 meters long. And you all are doing some significant science. So what we'd like is, we'd like you all to have the chance to tell us about it. Things that are absolutely revolutionary, utilizing the property of near zero gravity. And so let me turn it over to one of our specialists here at NASA, Dr. Lisa Carnell.
Oh, thank you, Administrator Nelson. It is truly a pleasure to be here today. And I'd like to take this opportunity to thank you, our remarkable astronauts, for your unwavering dedication, pioneering spirit in helping us advance the science. It's truly remarkable, as Administrator Nelson was saying, the significance of the research that you're conducting on our behalf cannot be overstated. Your work has yielded groundbreaking research in microgravity, from cultivating tomatoes to delving into the mysteries of bone loss and muscle atrophy, and studying how phenomena such as fluids, flames, and materials respond to the different gravity environments. So these experiments, they not only have a tremendous benefit for NASA and are helping us as we go further and stay longer, but they're also having tremendous benefit here on Earth as well. So we, in the Biological and Physical Sciences Division, we're dedicated to going further and staying longer in space. And the work and research that you're doing right now on the space station is paving the path for this, for humans to thrive in deep space and live longer there. So we thank you for that dedication. And not only is this benefiting NASA in our quest on the ISS and microgravity, but as we look to our Artemis missions and to the moon and Mars and beyond, we will be able to explore. And not only are you our heroes in microgravity up on space station, but you are architecting a brighter future for all of humanity. So as we celebrate 25 years in orbit of over 270 astronauts conducting science on board the International Space Station, we look forward to conducting our quest to explore, discover, and apply the knowledge gained to a better tomorrow. And so, again, we thank you.
So let's just start in all of your scientific experiments on the ISS. What has really engaged you the most? What are you excited about?
Great.
Well, that's a difficult question to answer simply because there are so many interesting experiments up here. The International Space Station is an incredibly versatile laboratory, but one of the things that really appeals to me is the idea of printing tissues, human tissues, for example. We have a biofabrication facility up here that allows us to print tissue simulants, for example, even simulants of human organs, and take advantage of the microgravity environment, which allows us to print in 3D rather than in an Earth laboratory where it's usually cell cultures are grown in a two-dimensional surface. And I think that's a very, very promising technology and very, very interesting one that we've been working with during our mission so far.
I'll
What would
echo
be
what
an
Andy
example,
said. It's
by the way,
really
of the
hard
tissue that you
to
are
pick.
creating?
Well, so for example, a human heart that allows us to study cardiac functions. I mean, if we look far in the future, perhaps we could print organs rather than relying on organ donors. A lot of people on Earth require organ donation, and unfortunately, we're limited on the supply, and a lot of people aren't lucky enough to have an organ donated. So perhaps in the future, we would be able to print organs, and rather than having to rely on donors.
By the way, is there an experiment going on that you're actually looking to print a retina of the eye?
I'm wondering, that might be on the next increment. For ours, as Andy said, we were working on printing cardiac tissues, but I believe that is going to be done in the future.
Okay, Dr. Carnell.
Okay. Well, thank you again for this opportunity. And I'd just like to ask, how can space experiments enable game-changing advancements right here on Earth?
I think that's one of my favorite parts of the experiments we do, especially the biological experiments. While many of them also have implications for us going further in space, and especially on longer duration missions, because this environment of space also very much is analogous to the effects of aging on Earth. A lot of the things we study up here in the microgravity environment carry over directly. For example, we just last week wrapped up an experiment called Moghbeli that's going to be coming back with us on our vehicle. And in that, we were studying in the life sciences glove box right next to us. We were looking at bone marrow MSC stem cells and the effect of the microgravity environment and analogous to aging back on Earth, and understanding how those could be used to potentially, they have mechanisms to potentially repair and make bone cells. So we, up here in this environment, we lose bone mass over time. We counter that through exercise, but if we can understand the mechanisms that can be used to prevent and potentially even treat bone loss, not only for spaceflight, that applies directly to bone loss for aging. So many of the experiments we do have direct carryovers that help us back on Earth.
There's a lot of interest down here on the face of the Earth about what you all did on the robotic surgery technology. And that teeny robot really made a lot of exciting news last week, where surgeons in Nebraska remotely controlled the robot to do a series of operations on the ISS. And although it was a test, it was performed on simulated tissue. This really sounds like a fantastic breakthrough that even though you've got about a half a second delay, a surgeon on Earth can actually perform surgery on the ISS. And as you think about it, when we go to the moon, do it on the moon or on the Lunar Space Station Gateway, or ultimately do surgery on Mars. So tell us about how this research can prepare us for future space missions.
Yes, absolutely. So actually, I think Laurel was just working on this earlier today. But as you said, it's very exciting, obviously applicable to, back on Earth remote areas. But why we're setting it up here was to assess when there's a delay in the reaction and when there's a microgravity environment, how does that change those people on the ground performing remote surgeries? And as you said, when we start going further on longer duration missions, something that back on Earth might be simple, like having appendicitis and you get surgery, that could be a big deal if you're far away from home and don't have a surgeon on board. And because crews are limited and you may not be able to have a medical surgeon, especially not in every specialized in every field on board, to have that resource of being able to have someone back on Earth perform those surgeries will enable us to go on these longer duration missions further from Earth. So it's a real game changer.
I've seen this robotic surgery on Earth, and it's just amazing. The surgeon is 10 feet away from the patient, and the surgeon is looking into a 3D microscope in color. And his tools are the scissors and tweezers, and then a little basket to remove the tissue. It's just amazing here on Earth, how much more so to do it all the way from Earth to space. Dr. Carnell?
Yeah. So another quick question for you all. This is so exciting to learn from you. What is the most challenging aspect of doing space research?
Well, it's probably the small things like keeping track of everything. Everything up here has a tendency to float if you don't hold on to it, just like this microphone. And so things like removing screws or even getting samples out of a bag that we're going to study, keeping track of them and not losing them in the microgravity environment, that's probably the most difficult thing. Just because everything tends to float away.
I think one other aspect I'll add is we have, a crew up here of just a few people that we're performing these experiments that have been put together by all these scientists around the world that have dedicated, years of their lives to understanding these experiments and creating them, really. And we then carry them out, which I think we all feel very honored to get to do that. But we don't have the same level of understanding as those that have spent years of their lives working on this research on the ground. And so that's another aspect up here where making sure when we go to work on an experiment, we know what we're doing enough so that we don't lose science in the process.
And time delays might be a factor, as Administrator Nelson. As Administrator Nelson discussed. And when it comes to International Space Station, it's like about a second or so. But when it comes to the moon and beyond, it might be several minutes or up to 20 minutes for Mars. So we are using International Space Station as a test bed to prepare for that, and we are moving forward to it.
Okay, now I'm really excited about some of the advances that you're making in stem cell research in the medical field, and whatever you can share with that. Not only you've already mentioned the bone loss, but anything with regard to crystal growth in zero G. Tell us about this groundbreaking research focused on strokes, cancer, whatever it is.
Well, it turns out gravity is a very strong force, and it tends to, on Earth, overshadow many of the smaller forces. And so whether it's physical processes, chemical processes, biological processes, or human physiological processes, when we study things in space without the influence of gravity, we can study some of these smaller effects, some of these smaller forces and their influence on the processes, and it gives us a much deeper insight into the physics or the biology of whatever scientific experiment we're looking at. And so it really gives us a fundamental knowledge by studying things under weightless conditions. And for example, if we take protein crystal growth or material science, gravity plays such an important role that it limits the size of the crystal that you can grow. And up here, without that effect of gravity, crystals or materials, metals, for example, can grow much larger, and it gives you an opportunity to understand their growth mechanisms without it being affected by gravity.
Let me add a little bit about the protein crystallization experiment in space. In space, under microgravity, we can get better quality protein crystallization. And by analyzing that, we can know the detailed 3D structure of a protein. And by using a computer, we can easily narrow down the candidate proteins effectively using the results of the space experiments. That would lead to the enhancement of new medicine development.
Believe it or not, that was my primary experiment on board the space shuttle 38 years ago. And it was dramatic. Of course, very crude by comparison to what you do today, where I had no temperature control, I had no vibration control, everything was done by hand, and yet the dramatic difference of the identical crystals grown on Earth as compared to grown in microgravity was quite dramatic. Tell me some more about the stem cell research that you're doing. For example, it looks like that part of the problem in gravity on Earth, stem cells all clump together. And as a result, you lose a lot of the stem cells. They die clumped together. But in space, in microgravity, they are suspended where they're not all being lost. Are you having that as part of your experiment?
Yeah, so I think the study we just wrapped up using stem cells, and kind of as both you and Andy mentioned, when you have gravity, it overshadows a lot of things. And for up here in this weightless environment, in general, cell cultures can grow more like they do back on Earth, where they're three-dimensional, like tissues would be. And so the study we just wrapped up on bone loss, that was using stem cells, again, to see if we can understand the mechanisms behind bone loss, and whether that's from spaceflight or from aging, and use that then to counter it, either through treatment or prevention. And so, yeah, just a lot of incredible research, I think, that's directly applicable and will benefit us back home.
I agree.
Okay, questions?
Thank you, Administrator Nelson and Dr. Carnell. We'll now turn it over to media on the phone and on social media to ask their questions. If you're on the phone, please press *1. If you're watching on social media, please submit your question using #AskNASA. So we'll start here on the phone with Elizabeth Howell with Space.com.
Hello, everybody. Thank you for your time. This question is for Andreas. Can you talk a little bit about the virtual reality headset that you're working on with the exercise bike on the International Space Station and the experience of what it's like to be using that as opposed to going without? Thank you.
It's actually one of my absolute favorite activities on board the space station. It allows me to bike on 5 different routes through my home country, Denmark, including a mountain bike path through the woods, a path through the center of Copenhagen, and a path along the beach. And it is a game changer. It really makes a difference. There's just something about when you see yourself biking up a hill in the virtual reality headset, you just have more motivation to pedal a little bit harder than you otherwise would when you're just looking into the wall of the space station. I absolutely love it. It also connects me with nature. I feel like I'm out in the countryside biking, and it's wonderful. It really is. We live on board the space station, which is a very synthetic environment. We can't go outside. We're not in contact with nature, but this is as close as it gets, and I use it every single time I exercise on the bike.
Thank you, Andreas and Elizabeth. We'll go to our next question here on the phone bridge. Jim with NASATech.net.
Oh, thank you for taking my question, and thank you for doing this. By the way, I'm talking to you by phone, so whoever is responding, aside from Bill Nelson, I know your voice, if you could identify yourself. I'm very excited, and I've written a number of stories about the 3D printing of human tissue. And I'm curious about when the printing is being done, what is the raw material that's being printed? Is it human tissue that's been collected from any of you, or that's been transported up to the space station from Earth? And when this is actually done in real time for people, as one of you mentioned, whenever there is a transplant, for example, that's needed, what would be the process? Would some sort of stem cells or whatever be collected from the person needing, say, a heart, and those would be transported up to the space station and used as raw material in the 3D printing? And after the 3D printing was done, would there be a period of growth or some sort of nurturing before it's sent back down to Earth? Thank you.
Well, this is Andreas Mogensen answering. Those are all very, very good questions. We are still in a very early stage of testing the technology. Currently, we are receiving syringes from Earth with cells in them, and then we're setting up the printer and letting it print with those cells from the syringes. So they're not our cells. What we would do in the future, those are good questions. I don't think, at least us up here, are not able to answer that. And I think it depends on what we discover in this process, which, as I mentioned, it's still very early stages.
Thank you for your question. We'll now move on to Yami Yuri.
Hi, can you hear me?
Yes, we can.
Okay. Thank you for taking my question. Yusuke Tomiyama, the Yomiuri Shimbun, Japanese Daily. My question is to Furukawa-san. Through your experiment on orbit, what kind of technology in space is most promising for business? What do you think about this?
Okay, thank you for the question. Let me talk about cell gravity sensing experiment, which is from Japanese Space Exploration Agency. It tests the researchers' hypothesis how individual animal cells detect gravity. Previous studies indicate that individual animal cells detect gravity, but how it does so is greatly unknown. So it tests, analyzes the changes in tension in cell fibers that happens under microgravity. And that is a very upstream phenomenon, and followed by signal transduction and multiple biochemical reactions that lead to the lower stream osteoporosis, bone loss, or muscle atrophy. So understanding the very upstream phenomena could help prevent or treat the bone loss or muscle atrophy encountered during spaceflight. And as we discussed, possibly to the similar pathology on Earth.
And we'll take our final question. Elizabeth Howell with Space.com.
Hello, this question is for Jasmin. Can you talk a little more about the auroras that you saw on the space station and photographed a few days ago? And if you have some time, some photography tips. Thank you.
Can you just repeat the last part of the question, please?
Photography tips. Thank you.
Okay, I heard you were asking about auroras. I think I missed the last part of the question, but I will say I had never seen an aurora from the Earth, and it was something I was really excited to come see up here. I've been looking out for them since I got up here, and the auroras from up here are spectacular. Everything about looking back at the Earth from up here, I can't possibly tell you in words how beautiful our planet is. And that night in particular, it just, the green, and there's some green, some reds, it just swept across the surface of the Earth. And really, looking back at the Earth from up here, I love it because every time I look out the window, I'm in awe. And every time it's a little different, even if we're passing over the same part of the Earth. Whether the lights are different or the clouds or the seasons, the sun angle. So every single time I'm amazed at how alive and beautiful our planet is. And that specific night was definitely a highlight, seeing the aurora pass over the Earth.
So that's almost all of the time that we have for today. Andreas, Jasmin, Satoshi, thank you all so much, and we can't wait to see you back on planet Earth soon. Administrator, would you like to share some final thoughts?
Hey guys, the research that you're doing is a part of why we're in the golden age of space exploration. Thank you for what you're doing. We are going to keep the station going for another 6 years, at least. And now you are finally having breakthroughs in your research. So keep it going. Thank you, And we Earthlings are going to be the beneficiaries of what you all are doing. Thanks so much.
Thank you, Administrator, and everyone for joining us.
Thank you very much, Senator Nelson.
Station, this is Houston ACR, and that concludes the event.
Communications.